Hello everyone. As you know that I am doing previous year questions of fluid mechanics, which is from different exams like GATE, IES and IAS. So today I am going to talk about IES questions. Okay, so this will be helpful for mechanical engineering students and for the civil engineering students. So I am going to talk a topic based on hydrostatic forces on surface. So this is like engineering services part 1. There will be many parts. Okay, so this is about myself, and I have already completed the one chapter, that is properties of fluid. So if you have not watched those videos for fluid mechanics, please watch those videos as well. Anyway, we'll see this fluid mechanics hydrostatic forces on surfaces questions from engineering services examination. Okay. Okay, so this question it is came in engineering services 2009. Let's see that a tank has in its side a very small horizontal cylinder fitted with a frictionless piston. The head of the liquid above the piston is H. The piston area A. The liquid having a specific weight gamma. What is the force that must be exerted on the piston to hold the position against the hydrostatic pressure? Okay, so they're asking what is the force that must be exerted on the piston to be held in position it's against hydrostatic pressure. Okay, so these are the options are given. Okay, so there's okay. So this is actually its answer is actually B. Its answer is B. So this is like this is the pressure and the force. This is pressure and the force will be this. Okay, so obviously we have to multiply with the area. So this is actually gamma. Okay, so gamma HA. So it is like gamma HA. So answer is A. Okay, don't think like it is not a confusing question. It's like a straightforward question. Okay, so this is like pressure and just multiply with the area, we'll get force. Next question, which one of the following statement is correct? The pressure center is A. The centroid of the pressure press a point on the line of action of the resultant force. C is the centroid of the submerged area, always above the centroid of area. So this is actually the pressure center is a point on the line of action of resultant force. Okay, so the answer is B. Next question, let's see that it's like numerical question. The semicircular plane area of diameter 1 meter is subjected to a uniform gas pressure of 420 kilonewton per meter square. What is the movement of thrust approximately on the area about the straight edge? Okay, so these are the options. Okay, so let's see how to solve this. They're asking what is the moment of thrust approximately on the area about its straight. Okay, so this is the semicircle. The semicircle is given. Okay, is given in the problem. Okay, so it like centroid is like from here, so it is 4r by 3 pi. So this we have this gap. Okay, this gap we have to remember this. If you don't know, it's fine. If you know, it's fine. If you don't know, please remember this. Okay, 4r by 3 pi. So what is force? Like P into pressure into area. So pressure is given. Okay, pressure is given 420. It is 420, and area is pi by 4 d square. But it is like semicircle, so it will be half. So this we have to multiply by 4 d square. Diameter is given 1, so it has to be half. So this is nothing but it is like force. So what is movement? We have to take movement with this. So this force we have to multiply with obviously whatever it is, like this centroid. Okay, so that is 4r by 3 pi. Okay, so this is like P into H bar is nothing but this is H bar. Okay, so this is force and this is 4r by 3 pi. So r is, it will be 1 by 2, r will be 1 by 2, Okay, so this is nothing but 4r by 3 pi, r is 1 by 2, and this is like force, this is the force. So if you simplify, you'll get 35 kilo Newton per meter. So answer is A. Okay, I don't think it's like you cannot understand this question. Very simple question. Just get the force and just multiply with this like h bar. It is like 4r by 3 pi. You will get moment. Next question. Okay, like it's a formula based question. Horizontal oil tank is in the shape of cylinder with hemispherical end. If it is exactly half full, what is the ratio of magnitude of the vertical component of the resultant hydraulic thrust on one hemispherical end to that of the horizontal component? Okay, so they are asking the ratio. Okay, see, so they are asking a ratio for vertical by horizontal. So what is vertical force? It is like it will be hydrostatic force. Horizontal force will be nothing but it will be hydrostatic force. So that is rho g ax bar, you know that. Okay, so this x bar will be nothing, it is like 4r by 3 pi that we have seen in the previous question, and this is like rho g, and area is pi by 4 d square. So since they are saying half hemisphere, so we have to write pi by 4. I mean it should be pi by 4 d square into half. Okay, so this is nothing but horizontal force. Now vertical force is nothing but it's like weight. Weight of fluid displaced, that is nothing but is the don't select fluid displaced, but actually it's the weight of the fluid is nothing but is the vertical force. So this is rho g v. Okay, so like rho g into volume is 4 by 3 pi r cube, so it will be 1/4. So now we have to take ratio of pH PV by pH. So it is PV by pH. So if you simplify, you will get pi by 2. So the answer is P. Okay, next question. A rectangular water tank full of the thing has its length, breadth and height to the ratio of 2:1:2. The ratio of hydrostatic forces at the bottom at the larger to the vertical surface. Okay, so again like this question is like previous question. So first we have to calculate the hydrostatic forces, that is FH. So rho g ax bar. So area we have to write 2 into this is length 2x. So this they are writing in terms of x. Breadth is 1x, height is 2x. So area is length into breadth and height is 2x. So this is horizontal force. If you simplify you get 4 rho gx cube. Okay, similarly for hydrostatic forces larger vertical surface. Okay, so it is like it will be so exactly this will be the almost similar to the what is the like hydrostatic forces. Okay, so rho g 2x into 2x. Okay, so this will be half actually. Okay, so the height will be half here. So this half will have half will cancel out. So if you simplify, you'll get 4 rho gx cube. Okay, so these both are both are equal. So if you take a ratio, you'll get 1. So the answer is B. Okay, next question. So this question came is IES 2007 and IES 2004. Let's see that a circular plate 1.5 meter diameter is submerged in water with its greatest and least depth below the surface being 2 meter and 0.5 meter respectively. What is the total pressure approximately on one face of the plate? Okay. See, obviously they are asking total pressure. So total pressure is nothing but like it's like hydrostatic force, like rho g ax bar. Okay, rho g ax bar. So area is diameter is given pi by 4 d square. Okay, so here's this depth largest and and least, like h1 and h2 is given. So x bar is actually nothing but, it is like, h1 plus h2 by 2. We have to take average of that. Okay, so that they are putting here. So 0.75 plus 2 by 2. Okay, so if you simplify this, you'll get 24 kilonewton. The answer is C. So this we have to remember. If, like, the least and greatest is given height. Okay, so to get x bar, use this formula, that h1 plus h2 by 2, and put here, you'll get 24 kilonewton. Next question. A tank with 4 equal vertical faces of width L and depth H is filled up with a liquid if the force on one vertical side is equal to the force at the bottom, then the value h by L will be. Okay, so they are asking h by L value. So here obviously we have to equate the pressure at bottom side, okay, and at end side. Okay, so like this again, like it is what rho g ax bar that we have seen earlier. So it will be rho g h t into t. Okay, so for bottom side it will be this, and for side rho g t into h into t. So you have to simplify for h by t. So everything will cancel out. Okay, rho will cancel out. Okay, t to t cancel out, h to h cancel out. Okay, so only h and t will be left. So it will be 2. So the answer is E. Next question. The vertical component of hydrostatic forces on submerged curved surface is, okay, mass of liquid vertical above it, weight of the liquid vertical above it, force on a vertical protection on the surface, product of pressure at the centroid and the surface area. It is actually a weight of the liquid vertical above it. Okay, you can see how much important this question is. This came in 1998, 1995, 1993, 2003. Okay, so the same question, like 2 times in IES and two times in engineering services. So the answer is B. Next question. What is the vertical component of pressure force on submerged curved surface equal to? Okay, it's horizontal components, the force on vertical projection on curved surface, the product of pressure at centroid and the surface area, the gravity force of liquid vertical above the curved surface up to the free surface. So it is actually, what is the vertical component of pressure force on submerged curved surface equal to? It is actually the gravity force of liquid vertical above the curved surface up to the free surface. So the answer is D. Okay, so the vertical component of the hydrostatic force on a submerged curved surface is the weight of the liquid vertical above it. Next question. The resultant pressure of the liquid in case of an immersed body acts through which one of the following? Okay, resultant pressure on the liquid in each case of an immersed body acts through which one of the following? Center of gravity, center of pressure, metacenter, center of buoyancy. This is actually B, center of pressure. Okay, so this was the end of engineering services part 1 question from hydrostatic forces. We'll see more question from the engineering services examination. So thank you for watching. Bye bye.